Well, thank you very much, and it's truly an honor to be here and to be present on stage with such distinguished speakers. I wanted to talk a little bit about the topic of the panel, which is the state of AI today. It's very tempting, of course, in my line of business to talk about the future, but I'll try to stay very much in the present. And thinking about the present, I think we're very clearly emerging in this field from something that was largely a research and scientific pursuit and trying to approach something that you would call or refer to as an industrial pursuit or industrialized process. But we're not there yet. We're in this in-between place. And if we can bring up my slides, with that, I've decided to title this short presentation, Artisan AI or Artisanal AI or AI Artisans. Because in a sense, we're in this sort of in-between where we require a great deal of labor, engineering labor, and very highly trained, very specialized craftsmen that build the AI models that we can put into practice today. And because of that sort of artisanal aspect of things, we have some significant challenges today. I also was inspired by that to use this graphic, which is a print from William Morris, who was a leader in the arts and crafts movement. And if you know a little bit about the history of the decorative arts, I think the decorative arts, before entering into the Art Nouveau period, was also in this sort of transitionary time. And some of the same challenges happened then. Now, in order to get into this a little bit, I thought I would start by giving just a very basic primer on the practice of AI today. And so what we have today, if we can advance the slide, is really a significant dependence on machine learning. And this is going to be a little bit simple for some of you, but I'll make a point. Machine learning today, in the practice of machine learning, this isn't true necessarily for the fundamental research, but in the practice, machine learning today is really dependent on data. And in fact, largely speaking, in commercial practice today, that data is mined. It is the digital exhaust of human intelligence, of human activity. So for example, if we wanted to build a machine learned system that could recognize human speech, we record many, many hours of human speech, and then we employ human labor to label those recordings with their transcripts. And so here I have a small amount, a small example of this. In fact, today's machine learning systems, while extremely effective and high quality, depend on very large amounts of this data. You could say that machine learning systems today are slow learners, very much like biological learners. And so luckily, we have very specialized algorithms and very large amounts of computing power, so we can take thousands of hours of such labeled training data and feed that training data into our machine learning system. And as we do that, the machine learning system processes the data and produces a model. We've heard earlier about LSTM and about deep neural nets. Those are very popular forms of models today. Fortunately, while the training process itself requires sometimes substantial amounts of specialized computing infrastructure, the models themselves can be very cheap and easy to integrate into applications, can run even in a mobile device quite easily in many cases. And with that model, then we can feed input, such as an utterance, and as we feed it in this case, recognize the utterance, and usually recognize the utterance with very small error rate. Here, in this example, I have a small error. The error rates today are actually slightly lower in the laboratory than the error rates that you're reading right now on the live human transcription, typically reaching about sub 5% word error rates. Now, one thing about this entire process is it's extremely labor intensive and sometimes very expensive. Obtaining the training data requires a tremendous amount of privilege. In fact, it's so valuable in many cases that corporations like ours and many others actually try to hoard the data or monetize in various ways. The machine learning process I've depicted here looks automatic, but in fact, in practice, it is far from automatic. It requires very highly trained and oftentimes very expensive people like Dr. Bengio at the end there to operate these machine learning systems, set parameters appropriately, babysit the systems, and then integrating the resulting models into high value and useful applications is also a very delicate process. And so the whole process requires just tremendous amounts of craftsmanship. Furthermore, we see in this a lot of inspiration for talking about intelligence, not just machine learning, not just the study of machines that improve with experience and data, but about true intelligence. And why? Many, many reasons. Let's take this specific example, and now let's give it more data. But this time, not data in English, but we'll give it Portuguese. We'll go ahead and go through the whole labor-intensive process of labeling the Portuguese input data. We'll feed all of that data into our English-trained system, produce a new model, and not surprisingly, we will get a model that is able to recognize Portuguese speech. But magically, also, what we find in practice, and this is very important to a company like Microsoft, is that we can now feed English into the system, and magically, the English has improved. And if we were to train the system on Mandarin, we would find the Portuguese and the English have measurable improvements. And if we wanted to furthermore train this on French, we actually can find that we can take shortcuts in the training process and obtain with less computing power very high performance French input. So this sort of transfer learning effect is extremely important for a company like Microsoft that wants to create models for many, many thousands of different customers. But it's also something that is incredibly alluring and intoxicating, because anyone who has taken the trouble to learn a second language has experienced viscerally this type of transfer learning. And so while I would claim there's nothing biological going on here, there are some abstract biological inspirations, but really nothing truly biological here. It's just impossible not to think about biological intelligence when you see things like this in practice. And hence, we get sucked into a lot of hype about artificial intelligence. The hype is justified in some sense, but it is hype nonetheless. Now, of course, industry is just racing ahead to acquire the craftsman skilled labor to build these models and to integrate these things into products. And if you use Skype, for example, you might be aware that you can speak any one of 9 languages to anyone else who speaks one of those 9 languages and have real-time translation entirely done by this type of machine learning. This has tremendous kinds of consequences that we never predict. And one of my favorites is shown here. So please, if you could have the audio on the... since there's no audio, let me explain. Much to our surprise, when we deployed the Skype translator, we found that thousands of teachers on their own discovered that they could use Skype translator in their classrooms in order to accommodate students with hearing loss, so they could integrate into normal classrooms in a way that was not possible before. And with that type of surprise to us, we were, of course, very motivated to modify the user interface for Skype in order to accommodate this type of classroom experience. These sorts of surprises are something that we see coming all the time. And so while industry is, in fact, racing ahead to build what it thinks are the high-value applications of AI, the things that we truly find are the highest value are things that are invented once we get things out at scale. Now, I spent some time talking about language and language translation and speech, but in fact, as we see, there are other reasons why we get intoxicated about the idea of intelligence. As was mentioned a lot this morning, we are very rapidly endowing machines with the gift of sight. In fact, if you'd like to try this yourself, you can use your own smartphone and go to captionbot.ai and just point your smartphone at anything, and deep neural nets will attempt to tell you what you're looking at, synthesizing not only its understanding of the image through deep neural nets, but synthesizing a plain English sentence using deep neural nets as well. Computer vision has tremendous impacts, and as I was reflecting on some of our speakers, I thought I would use just one simple example, maybe an obvious example, from healthcare. We are finding, as has been mentioned several times today, tremendous numbers of innovators around the world, including at Microsoft, in the applications of advanced computer vision to medical imaging. And what does this actually mean? It's not exactly a replacement, in this case for radiologists, but a tremendous productivity improvement and augmentation of what radiologists are able to do. So if we could advance to the next slide, please. So if we look at what radiologists do today, they use radiotherapy planning tools. And when they look at these scans, they look at these scans one slice at a time. Usually you have several dozen or even several hundred slices in these scans, and you go through pixel by pixel drawing the outlines of a mass or a tumor of interest. But using advanced computer vision, you can work in 3D and looking at cross sections, do a tremendous amount of kind of co-labor with an AI in order to get tremendous speed ups, both in the quality of the radiotherapy planning as well as in productivity. This dramatically increases the productivity of radiologists, but also increases their satisfaction in work, increases their ability to engage more productively with surgeons and with patients, and overall improves the quality of the outcomes. Now, all of this, however, is still, as I said, artisanal. We find over and over again that the machine learned models that we produce, the most valuable models are highly specialized for a single application. If we build a model for one type of imaging device, that model, by and large, does not work or is not able to adapt itself to other types of imaging devices. We have to find now craftsmen to build new models. And so what is very important in the democratization of AI is to somehow build the tools that allow innovators the ability to innovate. And Microsoft, as well as many other tech companies, large and small, have been racing ahead trying to do this. In the case of Microsoft, we've been developing more and more of our cognitive services to enable people to build their own machine learned models. And so, for example, with cognitive services, the Federal Trade Commission and the FBI have been able to build new AI-powered tools to track down scammers. With the bot framework, we're finding a tremendous number of startups starting to deploy health bots that give people much more ready access to healthcare advice. And with things like the Cognitive Toolkit, or CNTK, we're giving innovators access to extremely large amounts of computing infrastructure in the cloud. And all of these together are just the tip of the iceberg. They still require a level of expertise and training and craftsmanship, but they are the first steps, I think, on a 100-step program to provide the tools for people around the world access to AI and its power. Now, I wanted to make a closing comment. There was a lot of discussion this morning about exponentials, and I think exponentials, of course, are, in a way, if you wanted a logo for this age, you could use this term, use this graphic. Exponentials indeed have had this transformative effect, but they are also markers of inflection points in human history. And I thought one interesting way to illustrate this is that in this case, we can overlay the development of books. And so just before the Gutenberg Bible and the invention of mass-produced movable type in the mid-1400s, historians estimate that there were about 30,000 books in all of Europe. And they were very precious commodities controlled actually by the state or by the church. After the invention of movable type and the printing of the Gutenberg Bible, within 50 years, there were 8 to 9 doublings, both in the spread of printing presses throughout Europe and in the access to books. And in fact, by 1500, historians estimate that there were 12 to 13 million books in Europe. This had a transformative effect. You could really think of this as a medieval Moore's Law. And this transformative effect ushered in, ultimately laid the foundation for the Renaissance and had an uplifting effect on all of humanity. We may actually be in a similar period today with the emergence of practical machine learning and AI. But we mustn't forget also the challenges and disruptions that this causes. For sure, the church was disrupted by the emergence of movable type. But ordinary people were also transformed. By 1550, economies throughout Europe had changed to where it became a necessity to learn this very difficult skill, namely how to read, a skill that requires years of formal training. And as we think about the emergence of AI, we should also try to be thoughtful about the disruptions that occur and the level of new training and new worldview and mindset that we must spread and instill in people. And so as we look to the future of AI for good, I would ask all of you to think back to how you would feel in 1550 with a sudden realization that your children must now learn to read, and try to project today what it is that our children must understand and learn about machine learning and artificial intelligence. Thank you.
You did really a wonderful job in giving it some insights on where industry is at in the development of AI. As our one industry panelist, though, I want to shift us in a slightly different direction, and that's to the oversight of AI and the oversight of research. What should be researched, whether any parameters should be put on that. Microsoft is one of the founding partners in this new partnership in AI. It's not totally clear yet what functions that partnership in AI will or will not serve. But as a member of the management team of Microsoft and an industry leader, I'm wondering whether we can rely on you and other members of the management team to engage in effective industry oversight, or, because we've had a pretty mixed history with that in the past, or whether the pressures you are under, economic and otherwise, whether they are such that you need more direction, more oversight from the community represented here.
Actually don't, so thank you for the question. And we are actually very proud of our participation in the partnership on AI. And I think the partnership on AI has been making tremendous progress in really setting its terms of reference. I actually don't see this as an industry versus non-industry issue, but really something that pertains to the entire technology and even the research community. I remember in 2009 when there was a controversy in Iran. There was a contested election, and a tremendous number of people were using social media in order to speak freely and to assemble freely in protest of this contested election result in Iran. And you might remember that there was something called the Iranian Twitter revolution. Suddenly one day, all of the internet traffic in and out of Iran was cut off. It turns out I had just started work at DARPA at that time, and the State Department of the United States was quite alarmed because it came to light that US developed technologies to detect cyber intrusions into corporate and government networks were being used by the regime in order to hunt down and prosecute, and in some cases, execute people who were using the internet and social media. This was, admittedly, for the research community itself, in my experience, one of the first times when the simple lessons about the dual-edged nature of powerful technologies came to light. In fact, I was unaware of any academic researcher at the time who thought that these cyber intrusion algorithms and technologies could have such intent and malpurpose. There has been tremendous progress in the research community since 2009 to today, tremendous enlightenment about that dual-edged nature of the technologies that we develop. And I think it is absolutely up to not just industry, but industry and research and the technology innovation communities to keep advancing that enlightenment. It is not something for industry alone, but really for the entire technology community.